Okay, the other one, we just left off 18, so I'm going to start it from the beginning. All right, the results of rolling a die are shown in the table. What is a theoretical and experimental? So remember, you should always start off with theoretical, okay? So let's start off with theoretical, because that's the one that makes more just common sense to us. So the probability of rolling a 5. So theoretically speaking, if I have a die, one side has a 5 on it, and then there's 6 other sides. Now let's do the experimental. So the experimental of rolling a 5, I go here. There were 10 rolls, and then I've got to calculate the total. So I'm going to add up 13 plus 9 plus 20 plus 8 plus 10 plus 15 to give me 75. And then I'm going to divide top and bottom by 5, giving me 2 over, forgot, 75 divided by, oops, 75 divided by 15. Okay, so my experimental probability is 2/15, and my theoretical is 1/6. 19. All right, the table shows the types of vehicles passing through an intersection. Based on these results, what is the theoretical probability? So theoretical probability. The next vehicle passing through the intersection will be a truck. So theoretical, we do not worry about data. So to be honest, you can get rid of this. We want the theoretical, okay? So theoretically speaking, there's one truck, okay, because it wants the intersection will be a truck. There's one truck, and there's 1, 2, 3, 4, 5 possible different types of vehicles. So our theoretical probability is 1/5. 20. Mr. Noss is rolling a number cube with numbers 1 through 6 and spinning in the spinner shown below with 5 equal spaces. What is the probability the die will land face up on the number 1? Okay, so that's 1 out of 6. One side has a 1 on it, and there's 6 total sides. And means multiply, the spinner will land on the trapezoid. So hopefully by this point we know what a trapezoid is. It's that one. So there's one trapezoid, and there's a total of 1, 2, 3, 4, 5 spaces. So over 5. Express your answer as a fraction in simplest terms. We multiply across. 1 times 1 is 1. 6 times 5 is 30. So there's a 1/30th chance. 21. Wheelchair marathon times are displayed in the stem and leaf plot. How many marathoners finished the race in at most 100? So at most means that's our maximum point. So at most 100. So 100 counts, 100 counts. 101 is too much. So then 60 or 96, 95, 93, 93, 90, 86, 83. Those all work. So we would say 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 marathoners. Okay, at most. Lunch choices are shown in the menu below. What is the probability? So I see the word probability, I immediately think fraction. The student selects a turkey. So turkey, that's 1 out of 3 chances. And an ice cream. Ice cream, that's also 1 out of 3 chances. I multiply across. 1 times 1 is 1. 3 times 3 is 9. So I have a 1/9 chance. 23. How many different dinner possibilities could you choose if you can pick one side, one entree, and one dessert? All right, possibilities. It means fundamental counting principle, okay? Nowhere in there did I see probability, so I should not have a fraction. So you're choosing one from each category. So up for the side, I have 3 options. For the entree, I have 4 options. And for the desserts, I have 6 options. And now I just multiply. 3 times 4 times 6 gives me 72 different possibilities or different menu possibilities. 24. The number cube has numbers 1 through 6 shown below. You roll the number cube and spin the spinner one time each. Find the probability the number cube lands face up on a multiple of 2. All right, so for our cube, these are the sides of a cube. Multiple of 2 is 2, 4, 6, 8, 10, so forth. So 2, 4, 6. So that's 3 out of possible 6, which reduces down to 1/2. So that's 1/2 times. And the spinner lands on red. So I've got 2 different red sections out of 4, which also reduces down to 1/2. 1 times 1 is 1, 2 times 2 is 4. So I have a 4th chance. And last one, I believe. Okay, a total of 20 students were surveyed. First of all, it's 20 students were surveyed on how much time they spent on homework each night in minutes. The results are shown below. Create a histogram from the circle graph to represent. Every single time we see a percentage, you should be turning that into a decimal. Let's start with the smallest interval, which is 0 to 30, which is right here. So I turned 60% into a decimal by going over 2, so that's 0.6 times, and remember we had a total of 20 students. So 0.6 times 20 gives me 12. So I go back to my histogram, I go all the way up to 12, and I fill it in. Okay, my next interval is 31 to 60, which is here. Turn 20% into a decimal, which is 0.2, and I'm multiplying by my total, which is 20, which should give me 4. So now I go up to 4, try to keep my intervals the same width. Next interval is 61 to 90, which is here. So I turn 5% into a decimal by double dipping, which is 0.05, times 20, which is 1. So I go to 1. Now, there's no 1 on the frequency, but 1 is in between 0 and 2, so I have to cut it in half as best as I can. Don't go all the way up to 2, because that's not right. Maybe even move it down a little bit. There we go. Okay. And last but not least, I have 91 to 120, which is 15%. Boom, boom. 0.15 times 20 gives me 3. So I go up. Once again, 3 is in between 2 and 4, so I should go halfway. And that is my frequency table. All right, study hard and come prepared.